Imagine turning the sound of your voice into a flash of light. It sounds like something straight out of science fiction, right? Like some kind of modern-day alchemy. But what if I told you it's not fiction? It's a real, observable phenomenon, and honestly, it's one of the strangest and coolest puzzles in all of physics.
So let me just ask you straight up. Can you turn sound into light? I mean, it feels like an impossible question. It's like asking if you can turn a whisper into a star. But the answer, under some very specific and very weird conditions, is a resounding yes, and it will absolutely blow your mind.
And this is what it looks like. Nope, that's not some fancy CGI or an artist's rendering. You are looking at a real photograph of a single, tiny bubble trapped in a flask of water that is literally glowing. And the craziest part? That little spark is being created and held perfectly in place by nothing more than powerful sound waves.
Now, there's a scientific name for this, of course. Sonoluminescence. Sono for sound, luminescence for light. Simple enough, right? But the how behind it all? How sound waves can crush a tiny bubble so intensely that it actually glows? Well, that's where things get really, really interesting.
To really get to the bottom of this mystery, our investigation has to start at the very beginning. And like so many incredible scientific breakthroughs, this whole thing was discovered completely by accident.
The story kicks off way back in 1934, when a couple of scientists basically just stumbled upon it while they were working on sonar. For decades, it was just this weird little curiosity nobody really understood. Then, in 1960, a theory popped up suggesting the light was coming from intense heat. But the real game changer? That came in 1990, when researchers finally figured out how to trap and stabilize a single glowing bubble, which meant they could finally study it properly.
And that first discovery was just a classic happy accident. Back in '34, Hermann Frenzel and H. Schultes weren't looking for some new kind of light. They were just trying to use ultrasound to make photographic film develop faster. But then, as the quote says, they saw these strange little dots showing up on their film, and they had this brilliant moment of insight to realize the bubbles themselves were glowing.
Now, what they first saw is what we call multi-bubble sonoluminescence. Just think of a chaotic, fizzing cloud of tiny, unpredictable flashes. For decades, trying to study it was like trying to analyze a firework from the inside. It was just too messy. That's why the 1990 breakthrough, single-bubble sonoluminescence, was such a huge deal. By trapping just one bubble, scientists suddenly had a stable, predictable flash they could watch over and over again.
Being able to study that one stable bubble let physicists get a really good look at the mind-bending physics going on. And it wasn't long before it got this awesome nickname, a star in a jar. So, what in the world is happening inside that jar to deserve a name like that?
It's this incredible four-step cycle that repeats thousands of times every single second. Okay, so first, a sound wave creates a little pressure trap in the liquid that holds a tiny gas bubble in place. Next, as the sound wave cycles, the bubble expands, soaking up energy. Then, the sound wave reverses and the bubble collapses. And I mean it collapses violently. We're talking faster than the speed of sound. And finally, right at that moment of maximum compression, all that energy gets released in one brilliant, tiny flash of light.
And when I say flash, I mean it's almost impossibly brief. The light only lasts for a few hundred picoseconds. That's trillionths of a second. The bubble itself at that moment is only a micrometer across, way smaller than a single red blood cell. And yet, get this. The flashes are so perfectly regular that they can be more stable and precise than the high-tech electronics creating the sound waves.
Okay, this is where the physics just goes from fascinating to completely unbelievable. You've got all this energy from a sound wave being focused into this one microscopic point. So the big question on everyone's mind was, just how hot does that bubble get? Well, by studying the light coming off of it, scientists came up with an estimate, and the number they landed on is just staggering. It's around 20,000 Kelvin. To put that number into perspective for you, the surface of our sun is a little less than 6,000 Kelvin. So this tiny bubble, for a split second, is nearly 4 times hotter than the surface of the sun. And remember, this is all happening inside a flask of room temperature water. It's just wild. So we know what happens, and we've got a pretty solid idea of how it happens. But that leads us to the biggest question of all, the one that physicists are still arguing about today. Why does it glow? What is the actual mechanism that turns that insane heat into visible light?
There are a few main suspects. The most popular one is that the gas inside the bubble gets so hot it turns into a plasma, where atoms are literally ripped apart and this superheated plasma just glows. Makes sense. But then there are more exotic ideas. One theory even suggests the light is being generated from the vacuum of empty space itself, a bizarre quantum effect that some have even compared to the radiation from black holes.
But the theories get even crazier. Some researchers have wondered if the temperatures inside that bubble get even hotter, maybe hot enough to actually trigger nuclear fusion, the exact same process that powers the sun. It's a hugely controversial idea that's been dubbed bubble fusion.
Now, I have to be really clear here. This is a massive claim, and for the most part, the broader scientific community is, well, they're pretty skeptical. While a few experiments have hinted at it, the results have never been successfully reproduced by other labs.
But just when you think the story can't possibly get any weirder, it takes one last amazing twist. It turns out that this bizarre star-in-a-jar phenomenon isn't just something we cooked up in a lab. Nature figured it out first.
Everybody, meet the pistol shrimp. This tiny creature snaps its claws so incredibly fast that it literally boils the water around it, creating a bubble. When that bubble collapses, it creates a sound blast over 200 decibels. That's louder than a gunshot, and a shockwave that stuns its prey. And for a split second, it also produces a flash of light. They even gave it a name, shrimpoluminescence.
So we've gone from a lab accident all the way to a shrimp's claw. Sonoluminescence just shows us that the universe is packed with these hidden wonders. It proves that incredible energy can be hiding in the most ordinary things, like a simple bubble in water. And it really leaves you with one final thought. If sound can create a tiny star in a jar, what other extraordinary cosmic secrets are hiding all around us, just waiting to be discovered?